Now for part four, as we go over the mole in chapter 10 and week 5 of chemistry online. Left off talking, we went represented particles to the mole, which is atoms, molecules, formula units. We also went the mass to mole. That's anything dealing with grams or how much does it weigh. And then we can also go volume. And what makes the mole so versatile is you can end up changing and converting into anything, which then allows you to go to volume to mass and vice versa. But to go volume, it's only with gases, and that's where we'll keep it. It's always got to be at the same temperature and pressure because we know as temperature increases, your volume increases with gases, and as pressure increases, it changes the amount of stuff. So we got to keep it at the same constant temperature and pressure, and what we call that is STP, standard temperature and pressure. So we're going to keep it at 0 degrees Celsius and 1 atmosphere of pressure. Pressure has a couple of different units. Can be 1 atmosphere, 101 kilopascals. So there's a lot of different units you can use for pressure. But just know, any problem I give you or in first year chemistry you're starting with, it'll all be at STP. So there's the key. You don't have to look off of the periodic table because any gas, regardless if it's a molecule, an atom, as long as it's a gas, will have a volume of 22.4 liters per every 1 mole. There's your parentheses. And that's always called the molar volume. It's something that doesn't change as long as it's any gas at STP, same temperature and pressure. And that's going to always be 1 mole of any gas at STP is 22.4 liters per mole. So these are real easy. Again, always start with what you're given, the 4.59 mole. And you're changing to a volume. And notice they always say STP because it has to. At least now, we change it later in AP or second year chemistry. But start with what's given. And now in this case, if I'm starting with a mole, the 1 mole goes on the bottom, the 22.4 liters on top. So I multiply. This one, if I start with the liters, the 22.4 liters will go on the bottom of my conversion rate. So I will divide by 22.4. And then if I want to go, what's the volume of grams? Okay, well, hey, was that a volume? Is that a mole? No, so you got to change grams to moles first. So this is a 2-step problem. 8.8 grams. I got to put the grams of this on the bottom. So you got 12 plus 4. Remember, you got to add those for masses. What's on the periodic table? Carbon's 12, hydrogen's 1. 1 times 4. So that's going to be 16. 8.8 divided by 16 changes it to the mole. And then you got 1 mole on the bottom, 20, and then multiplied by 22.4. Gives you 12. Because, that would make sense. 8 divided by 16 is a half. A half times 24 is about 12. Density, not going to spend a whole lot of time on, but you can find densities of gases. Why? If it's a mass, get it off the periodic table. If it's a volume if you're talking molar mass, 22.4. So it's always the same number for volume. The mass will change depending on what element you're using. If you notice here, for CO2, as far as a gas, at STP, they tell you. So there's the 22.4. The volume goes on the bottom. The mass, 12, and then 16 times 2 is 44 on top. Same thing for methane gas that we have there. So just summary right there. You change from the mole to molar masses to representative particles to volumes. Part 3 actually has a couple of different things in it in this section. Percent compositions are fairly easy. Because it's finding the percent of your worksheets. Take the part divided by the whole times 100. It tells you the percent that you would get on your homework, right? How many did you get right? Your part divided by the total times the percentage. You do the same thing here. So if I tell you in here that there are 29 grams of silver, 4.30 grams of sulfur, there's your 2 individual parts. You need the total, so all you got to do is add them together. So if I want to know the percent silver, take 29 grams divided by whatever that total is. If I want to find the grams of sulfur, take 4.3 divided by the total. Here they wanted the grams of silver, so 29 divided by the total, 29 and 4.3 is 33. And they just check themselves at the end, that you can come up to 100. A percent composition of carbon and hydrogen. Again, what is the individual? So 2 carbons, 24, divided by whatever the total is. If I want just the hydrogen, it's 4 times 1, so 4 hydrogen divided by whatever the total is.